Hello and welcome to today's lesson. What we're going to do today is we're going to do some work with the graphing calculator. So if you have your own graphing calculator, you want to take that out and have it ready. And if you don't have your own graphing calculator, you can use the instructions that I posted in Google Classroom to go to the Park website, the NJSLA website. And the instructions are there for how to get to the graphing calculator. And you can do everything you want to do with the graphing calculator right on this one. So what we're going to do is work in section 3.2 to start if you're in pre-calc. This is section 6.3 if you're in algebra 2. And the first thing we want to do is evaluate some logs. So first thing is log of 42. And to evaluate the log of 42, you just want to use your log base 10 button. So this is log base 10 because there's no base written. And when we get to number 2, that's natural log base E, because it's ln. Those two buttons are built into the calculator. So if you look to the left of 7, you see log. That's specifically for log base 10, the common log. Next to the 4 is ln. That's specifically for natural log. Okay? So if you want to find the log of 42, you just hit log, the button next to the 7, and you put 42 and you hit enter. So the log of 42 is about 1.6232 if we round to 4 decimal places. And you'll find that we often round to more decimal places than normal because usually we round to like 1 or 2 decimal places. But since we're finding an exponent, we're going to round further because exponents are very powerful. And just to show you what I mean real quick, if we just think about what this is log base 10 of 42 equals what number? So we're finding 10 to some power that gives you 42. So if I want to check this in my calculator, I can do 10 to the 1.6232 power, and I'm going to get pretty close to 42. It's not exact because this is an approximation. We rounded to get this, but we're going to get very close to 42. If we only rounded to 1 decimal place like we're kind of used to, what would happen here is we would have used just 1.6, and we're not very close to 42 at all. So exponents are very powerful. They have a big impact on a number. So that's why in this unit, we're going to round out further than normal. Okay, and if you want to find the natural log of 15, hit natural log. That's the button next to the 4. Plug in 15 and hit enter. So nothing fancy to do when you want to evaluate common log or natural log. And rounding to 4 decimal places, just remember, since this is a 5, we're going to round this up to a 1. Okay, the next one is this. So if you printed out the handout, you can just follow along. If you didn't print out the handout, you want to write these down in your notebook. So just pause as needed and write them down, and then we'll get them in the calculator. So for this one, we're just going to type in what we see. So we're going to type in 2 times the common log. This is log base 10. So I just use the log button of 7. And what's important here is before we continue in the calculator, we have to close the parentheses. Because the only thing we're taking the log of is the 7. Even though they weren't written, that's the only thing that's inside the log. Then we have plus e to the 4th and a minus 1. So for e, you can do second divide. So if you forgot where that button was, it's second divide. Or you can do second ln. If you do second ln, so here's second and ln. You'll get your e. So I used second divide, but if I were to use second ln, it would set me up with the exponent. And I want to the 4th power, and then I want to subtract 1. So we have 55.2883 for that. And if you have a slightly older graphing calculator, it's going to look like this. Because when I did e to that power, it doesn't actually show the exponent raised up. It just puts that caret, and then whatever's in these parentheses is going to be what the e is raised to. So once again, make sure you close those parentheses before you put that minus 1, because if you don't close the parentheses, you're going to get a wrong answer. Okay? And then just for those of you who have the newer graphing calculator, just to show you, you have 2 log of 7. You also have to close the parentheses before you go ahead and do e to the power. But your calculator, if you have a newer one, or if you're using the online one, it actually raises the exponent up there. So before you put that minus 1, you want to get out of the exponent. So just use your right arrow button. Your right arrow is this guy here. And then you can put your minus 1. And you get the answer we got before. All right, so that's evaluating logs and the a base of E. And we can also graph on the calculator. So just to quickly kind of show you that, I have, let me graph common log. So here's common log. I'm going to go to Zoom Standard. So this is log base 10. And you can see that the calculator, it shows me a good part of the graph, but it's missing the part that comes down toward the asymptote. You might not even notice it if you're using a calculator that doesn't have the color graphing. So if I show you on the other calculator, log of x, you might not even notice that the calculator is not putting that part that comes down toward the vertical asymptote. But if you have a color graphing calculator, you'll notice it. It's just a limitation of the calculator. What's happening here is as we get closer to the vertical asymptote, the calculator, this graph becomes so steep that the calculator really can't graph it properly. So it kind of gives up in a sense and stops graphing. And it's just, again, a limitation of the calculator that you want to be aware of. Because even if this is the graph you're looking at, what the graph of the common log really looks like is this. So even though the graph looks like this on the calculator, if you were going to sketch it, you would sketch it properly the way that you know it's supposed to graph. Okay. And then you can also do transformations. So if I wanted to move this, for example, up 2, I can throw a +2 outside of the parentheses. And you can really see the calculator's limitations here if I do the horizontal shift. So let me move that 3 which way? To the right. Yep. So if I move that 3 to the right and up 2, it looks like this. And that's really not what the graph looks like. What the graph should look like is it should have gone 3 to the right, moving the asymptote to 3 and the intercept to 1, and then up 2. So the graph really should look like this. It should not chop off at the end there. So even though the calculator shows it kind of incorrectly, make sure that if you were to sketch it, you sketch it properly. Okay, so continuing on, we've evaluated common log and natural log. The next thing we want to do is evaluate log with other bases. So this part's going to take a couple minutes because depending on the calculator you're using, there's 3 different things that can happen. So I have to show all of them right now. And I'd have to do this in class if we were in class as well. So here's the example we're going to do for log base 4 of 17. And if you think about that for a minute, you should be able to get some idea of what the answer will be. Because what you're solving here is 4 to what power is 17. So since 4 squared is 16, we're expecting an answer just a little bit bigger than 2. We should get an answer a little bit bigger than 2. Okay, so here's what may happen when we try to do this in our calculator. So if you have a newer graphing calculator or you're using the online calculator, if you click Math, that's this button right here. And then as it says, scroll down past 9, 8, 9, there we go. If you scroll down past 9, past 0 to A, log base, and some of your calculators won't have this, so don't panic if you don't see it. We'll get to your calculators in a minute. But we have that log base there. So if we hit enter, we can plug in exactly what we want. So we can plug in a base of 4 and 17 for the input for the log. And there's the 2 points, just a little bigger than 2 that we were expecting. So 2.0437 if we round to 4 decimal places. So if you're lucky enough that your calculator has that feature, you can just pop that right in. Another possibility with your calculators, just to show you another thing that can happen, this is the least common, but when you hit Math, so I hit Math and I scroll down past 9, past 0 to A. If you have a slightly older calculator, you might get this where it says log base. Okay, so if it says log base, here's what you do. You put your input and then a comma and then the base. So if we want log base 4 of 17, what we will do is put 17, a comma. Comma is on the calculator right above a 7, right there. Okay, so I put the input, what we're taking the log of, and then the base. and that'll give me the same answer that I had before. And then there's a third possibility. If you're working with a slightly older graphing calculator, when you go to hit math, and then you go to scroll down past 9, past 0, you don't have that feature at all. It just doesn't say log base at all. So if you have an older calculator, you just don't have that feature. I would not go out and buy a new calculator for that. Even if you're going to go and take calculus and beyond, you're fine. You don't need a new calculator. So I'm going to teach you a formula in a minute that you can use, and everyone's going to have to learn it. So don't feel like, like you're doing extra work or something. Or you can always go to the online graphing calculator I showed you because it has this feature. So those are the options that you'll have. Okay, so let's get to that formula next. And in your textbooks, here's the section if you're pre-calc, here's the section if you're algebra 2. And this is called the change of base formula. And even if your calculator has the fancy log base feature, you have to learn this. It's part of our curriculum, so everyone has to learn it. And here's how the formula works. What the formula allows us to do is if we have a log and we don't like the base. So if I have log base A here and I don't like base A, I want a different base, I can change the base. The way that I do that is I make a log with a new base. So in this case, I selected B. And what was inside the log goes inside the log up top. And what the old base was goes below. So the way that I remember that is the base belongs below. That's alliteration for you. So the base belongs below will help you remember that the old base goes on the bottom. So to understand it, you need to see a couple of examples. So let's take a peek at this one. So if we want to evaluate log base 4 of 17 using this change of base formula, either because our calculator doesn't have the fancy feature or because we all have to learn this formula anyway, what we can do is we can change the base. And the base we want to pick is one that's built into the calculator. The calculator has log base 10 and it has natural log. So those are the ones that you want to choose from. So we pick whichever one we want. I'm going to guess you like common log better, regular log. So what we do is we make a fraction. We use our base up top. Okay, so you do common log up top, common log on the bottom. So I'm using base 10 for these. What we are taking the log of goes inside. The old base goes inside the log on the bottom. So that's what we're looking at. That's the change of base formula using common log. And if we put that into our calculator, the common log of 17, close those parentheses before you divide by the common log of 4, we will get the same answer we had before to this problem. And the answer we had before to the problem was 2.0437. So it works. So I'm going to write that down here. And you can choose any base you want. So I think you guys probably like common log best. But we can do this with any base we want. So I could redo the same problem using a different base. So if I wanted to redo this using natural log, if I for some reason don't like base 4, I can pick a new base. I create a fraction with whatever log, whatever base I want, top and bottom. And what goes inside up top is whatever we were taking the log of. And what goes inside the log on the bottom is the old base. The base belongs on the bottom. And if I put that into my calculator, same answer. So you can do any base you want. The reason we pick base 10 or base E is because those are the ones that are built into the calculator. So technically, I mean, you could change them both to log base 3 if you wanted. So if you wanted to change this same problem using log base 3, you do log base 3 of 17 up top, log base 3 of 4 on the bottom. And if you were to do all the work to put that in your calculator, you get this anyway. But this is a lot of extra work. You wouldn't pick base 3. What you want to do with the change of base formula is pick natural log or pick common log. And again, that's because those are the ones that are built into the calculator. So this would give you the same answer, but you would never pick that. Okay. All right, let's get another practice problem. So here's that formula we're using. Let's evaluate this in our calculators using the change of base formula. I forgot to put that in the directions, but let's use that change of base formula. So you can pause and try it on your own if you like, or you can follow along. So pick the new base that you want. So you guys probably want common log base 10 over log base 10. I would pick natural log because if you're going to continue on into calculus, you use natural log way more often than common log. But I'm assuming you guys like common log better right now. So I'm going to pick log base 10 over log base 10. The 0.3 goes inside the log up top, and the old base goes inside the log on the bottom. And if we put that into our calculator, with log 0.3, close those parentheses before you divide by log of 2, you'll get negative 1.737 or negative 1.7370. Either way is fine. We're not doing significant digits like you might in a science class. I think you guys call them sig figs. We're just rounding. So when we go to round this to 4 decimal places, what happens is after the 9 is a number larger than 5. So we're going to have to round the 9 up, which is going to make that a 10 basically. So we get a 0 and we carry a 1 over here. So 737 is the decimal part. And if you want it to have 4 digits, just put the 0 on the end. But either one of these is fine. And just to show you, if you do have a fancier graphing calculator, if I ask you to use change of base, you're going to have to use change of base. But if you have a fancier graphing calculator, you can certainly check using this feature. So here's log base 0.2. Sorry about that. That's regular 2 of 0.3. And you get the same answer that we got just a moment ago. So it works. Okay, continuing on in today's lesson. You'll get to practice all these skills in the Google form after we finish today's lesson. What we're going to do next is we're going to get a preview of what we're doing in the next few days. So for Algebra 2, this is section 6.5. And we're going to be looking at properties to expand and condense logarithms. So these are the properties. They might look kind of scary at first, but don't worry, we'll handle them together. It takes us a few days to really get everything down. One thing you notice up top is you have some restrictions here. So you see you have a greater than 0, a not equal to 1. Those are the same restrictions we're used to on the base of a log. So you don't need to memorize these, but you'll see them in the textbook and you'll see them when I present formulas to you. And then these over here say u greater than 0 and v greater than 0. That's because those are the things inside the logs. So do you remember when we had log base a of x, we had restrictions on a. Those should look familiar. And then we also had x had to be greater than 0 because the domain of this is only bigger than 0. Okay, only bigger than 0. Can't be 0, can't be negative. So that's the same reason these are here. And once again, you don't need to memorize this, but you'll see stuff like this in the textbook. And when I present formulas, you'll probably see those as well. So here are our properties. I call them properties 1, 2, and 3. They don't actually have, they're not actually labeled 1, 2, and 3. I just call them 1, 2, and 3 so that's easy to talk about them. And we're going to start by using properties to expand. So we're going to use the properties going this way. We can also use the properties to condense, where we'll go from this side to this side. But we're going to save that for another day. So let's begin by just expanding. So here's what the properties say. The first one says if you have log of a product, see how that's u times b? You can split that up into the sum of 2 logs. So if you have a product inside, you can make it log of the first factor plus log of the second factor. And we'll see that through examples. The second property says if you have log of a quotient, so see in here we have a quotient, that's a division problem. You can split that up into 2 logs. You take the log of the top, keep the same base, then you put a minus and take the log of the bottom. And the third rule says if you have log where the expression inside is raised to a power, so this is what's inside the log, you can take that exponent and swing it around to the front and make it a factor or a coefficient. So that's another way of expanding logs. So I think what we want to do first, because again, this is going to take us a few days to get comfortable, but let's go ahead and try some examples using these properties. So here's our first example. I have log base 3 of x times y. When you look inside the log, do you see a product, a quotient, or a power? You see a product. So what that means is we can rewrite this expression as a sum of two logs. So we take log with the same base, and we're going to have log with the same base. And what goes inside the first one is the first factor. What goes inside the second one is the second factor. And this has been expanded. That's it for today. These are one-step problems. They will get more complicated in the days ahead, but just to kind of get us started, we have a one-step problem. The next one is log base 2 of m to the 5th. So just so you know what this is log base 2 where m to the 5th is inside. With no parentheses written, we're assuming that m to the 5th is inside. And I'm making note of that because I want you to be aware that this would be completely different. If we had the entire thing including the log raised to the 5th, that's completely different, and you probably will never see that. Definitely not this year. So without any parentheses, we're assuming m to the 5th is inside the log. So the rule we're going to use is rule 3. That's the one that this looks like. So what rule 3 says is if you have log where the expression inside is raised to a power, you can take that exponent and swing it around to the front. So what we can do is take that 5, move it around to the front, make it the same size and same level as log base 2 of m. And that's considered expanded. For the next one, I have natural log. And when you look inside this example, do you see a product like this, a quotient, or a power? You see a quotient. So this is the rule we're going to use. And what that rule says is if you have log with a quotient or fraction inside, you can split that up and make it a difference of 2 logs. Just keep the same base. So we're going to have the natural log, and we're going to put inside whatever's in the numerator. And then we're going to subtract the natural log of whatever's in the denominator. And that's considered expanded. And one more here. I have log of the square root of w. The base for this log is 10. That's common log. So we don't usually bother to write the 10 in. When it's log and the base is not written, we assume it's base 10. And when you look inside here, at first you may not see a product or a quotient or a power, but we actually do have one of those scenarios. If we think back to the previous chapter, we know that square root can be written as an exponent of 1/2. So what this is log of w to the 1/2. So we can apply rule 3. We can take that 1/2, swing it around to the front. It becomes the same size as log, and it becomes a factor. It's no longer an exponent. So now it's 1/2 times, you can put a dot there if you want, but you don't need to. So it's 1/2 times the log of w, and that's considered expanded. So one thing right now is that you might be looking at these and saying, okay, I can do those, but I don't see why we'd ever want to. That I will be able to show you that a little bit over the next few days. But I'm not even going to attempt today to explain why we might want to do this. We'll just start off with these little practice problems here. Thanks for listening to today's lesson. At this point, you can go ahead and do the Google form to get some practice with the calculator work. I didn't put any of this on the Google form. I want to practice that more with you before you do that on your own. Thanks, guys.